Zoio.
Right, well, thanks everybody for coming. I'm going to do a presentation today on Spring in large, complex and dynamic applications. First, can I just maybe ask you guys, how many of you use Spring in your day-to-day job? Okay, so most of you. How many, well, okay, so I guess all of you, is it fair to say, I suppose it's fair to say that all of you are familiar with the basic kind of mechanics of how Spring applications work and so on and so forth. And I think that's probably going to be my starting point today, an assumption that you guys already have that basic grounding. But I guess as with all things, you kind of, you start off having a basic understanding, you write some applications, so those applications start off simple, and they get more and more complex, and they get bigger and bigger, and you ask them to do more and more things as time goes by, and eventually you start kind of, if you like, pushing the limits of the framework. You start getting to a point where you are trying to do things which perhaps maybe the framework wasn't designed for. Maybe you find things which perhaps are limitations in the framework itself. And I think this is really what I'd like to talk to you guys about today. It's really, to a certain extent, my experiences, and I suppose, to a certain extent, also an initial stab at a solution, or some solutions to some of the problems, or some of the experiences, some of perhaps the limitations that I feel I've encountered in working with Spring. I mean, I guess one thing that we must be very clear about is that, and I'm sure that you guys all agree, Spring is an excellent framework. It really has transformed the enterprise Java marketplace really, and application development space. And anybody who is used to having worked with the likes of EJB and pretty much anything that went before it, will attest to the fact that it really was and is a big leap beyond what came before. But I guess time moves on, and obviously we are all always, almost by nature, I guess, by instinct, looking for new ways and better ways to do things. And I guess this is, to a certain extent, where some of this is coming from. So just a little bit about me. I'm an independent developer and consultant. I've worked in Java for quite a few years now, and I'm familiar with quite a few open source projects at a fairly sort of detailed level. And I actively work on a few projects, including, I think it's about, well, certainly a couple that I've started myself and maintained myself, but also I'm trying to get involved also more in other people's projects, and I guess to a certain extent Spring is certainly one of those. So, I guess the obligatory background about Spring is obviously a leading IOC in version of control container on the Java development space. It has great APIs for Hojo-based development, third-party library integration, transactions, AOP, remoting, where it does a fantastic job at insulating some, frankly, quite horrible APIs that you would otherwise have to deal with. And I think that we all, certainly this has been my experience, I've always felt that Spring kind of works out of the box. It's very high quality. You always expect it to work, and it generally always does. And as I said earlier on, it's a de facto standard in enterprise Java. So let's talk a little bit about what are we talking about when we talk about large, complex and dynamic projects. There is some overlap in the definitions, because obviously when you talk about a large project, it tends to be more complicated, unless it's doing exactly the same thing again and again and again. Then you generally find ways to kind of refactor and find abstractions. So larger projects do tend to get more complex. So what I mean by large, I think large is, we probably all work on projects which have 1,000 classes plus. And I think that even a project of, say, 1,000 classes is probably what you consider a medium-sized enterprise application. And a large application would probably perhaps even go to several thousand classes, which in Spring terms would translate to hundreds of beans. So what are the implications? Well, you tend over time to get a slow build, deploy, and test cycle. So, I mean, if, for example, in your integration test, you're having to fire up an application context which has several hundred beans in it, it's going to take quite a long time to learn, and it's going to take quite a long time to run those tests. So, the end result is that it does tend to make getting that sort of initial level of productivity that you had right at the beginning of the project when you had a kind of clean workspace and you just starting off, things will start to slow down. I think that's the nature of large projects. Complex. So as I mentioned, there is an overlap between large and complex. When I talk about complex, I talk about many different possible configurations and wirings. Perhaps I should add also different layers of abstraction that certainly adds to the complexity of a project. And perhaps even multiple deployments. So if, for example, you're working on a product which has to be shipped to different locations, and locations of different customers, and different customers have different requirements. So your application has to be tweaked in lots of different ways. And that obviously all adds to the complexity of the project. So, dynamic, well, what do we mean by dynamic? Well, here I think I'm talking about frequent functional updates. So, I mean, sure, we can have configuration parameters in databases which we can perhaps turn on and off and so on. But I think all of us probably, I'm just really speaking for myself, find ourselves in situations where it would be nice to have it certain, it was just that little bit easier to kind of rewire the application, to find a way to make the application be able to reload, without having to kind of reload the whole thing. And I think that generally, certainly we find that in any application that's kind of running on a customer site and you want to do things to it, then restarts are certainly undesirable. Anything which you can do to improve that and to reduce the number of times that you have to restart is good, really. And I think that you run into a problem really when you find that you're in a situation where restarts are unacceptable, but they have to be done, but they take too long. Then you're basically in a situation where you really kind of hit a problem because essentially the business is likely to suffer by the fact that you're having to stop your application and restart it to reapply some new wirings or some new classes, some new settings. So, okay, question: how does Spring cope? Spring context can take quite a long time to load. So, I mean, I find that it generally takes perhaps about 20 seconds for a reasonable sized application, decent PC. If you say maybe 30 tables or so running a Hibernate and you've got a whole bunch of business objects, it could take probably about 20 seconds. For a very large applications where you have lots of different perhaps components with even web applications and maybe lots of databases and so on, it can take much longer. And certainly if you're using something like Hibernate, it does slow the load time down quite a lot, perhaps even by half. So I think for me that's probably the biggest problem with size. What about complex? Rick should be able to correct me if I'm wrong here, but basically my understanding about Spring is we essentially have a flat bean namespace. So it really means that when you define a bean, it's generally visible across your your entire application. I mean, there are exceptions and there are ways around certain situations that you might encounter, but that's generally the situation. There's no kind of concept of, if you like, first-class concept of modules in, I guess, in the existing Spring. That is coming with Spring OSGI. That's the kind of, it's big developments on the horizon, which I'm going to talk about just briefly in a moment. Overriding, something we have to do all the time. We have a particular configuration that maybe is our default configuration, our default wiring, and we're in a situation where we want to change the way it's applied. So what do? Typically, we add another application context to definition file, XML file, to our application context. And that has a B definition with the same name as the one that we're trying to override. And effectively what happens is the last B definition that gets loaded is the one that counts. So you get a mechanism there for overriding B definitions, which kind of works, but I think that it is, in my opinion, a little bit crude. I think that there is a better way of doing it, which I'm hoping I can show you. Then imports is another, I guess, technique, if you like, for managing complexity within a Spring application. And it's quite useful for encapsulating B definitions. So what you have is, let's say, for example, you have some common components, common B definitions, which may be used by different other components. Then you can pull those common beam definitions into a single file, and then you can reference those from another file using imports. And it's quite a useful technique for encapsulating that relationship. But where it does actually become problematical is it's actually the out-the-box technique for imports is quite inflexible, because effectively what happens is when you import a beam definition XML, then you bring in all those beams that are defined within that XML. Now let's say, for example, you want to then go and override that particular XML or a particular beam definition. Then you can override the one that you want to override just by doing that, adding an additional file. But you still, unless you're going to override every single beam that gets imported, you're going to have a whole bunch of beam definitions which are kind of redundant, which are basically floating in the application context. So it works, but I think it's not quite right in my view. Dynamic. So that's the third kind of aspect of these kinds of projects. Spring has a clear life cycle. You can start and shut down application context cleanly. So that certainly helps. It's not completely trivial. It's not very difficult, but it's not completely trivial to add new beam definitions to an application context. And I think it would be nice if it were completely trivial. It'd also be nice if beams were reloadable. At the moment, our reloadable mechanism is basically, with Spring, is effectively through scripted beams. So I'm not sure how many of you guys are familiar with the scripting support that's available in Spring 2. But basically, you can implement your service classes using Ruby or JRuby or whatever, using the scripting language. And that has good support for dynamically reloading those implementations so that you can, if you like, change on the fly in an existing loaded application context. But it's only really available in a scripting scenario. If you want to use Java and you want to have dynamically reloadable beams, then there's no kind of support out of the box. So the end result of all of this is that rewirings generally require a restart, and that, as we mentioned, for a large application, can take quite a while, and therefore be quite painful. So, talk very briefly about Spring OSGI. Spring OSGI is, I think, going to address a lot of these problems. Can I have just a show of hands? How many of you guys are familiar or have heard of or have know a little bit about Spring OSGI, or even better, tried it out? Have any of you guys come into contact with it? Okay. Just at any point, if you have any questions, just stop it. shout at the stop. Okay, I'm going to talk very briefly about Spring OSGI, but it will be brief because the presentation isn't really about Spring OSGI. But, okay, let me ask another question. How many of you guys use Eclipse as your plugin? Okay, so pretty much all of you. Most of you at least. So, what you maybe don't know about Eclipse is that it uses OSGI over the covers. So, the actual Eclipse plugin implementation, if you like, is using OSGI as an underlying framework. And it has some real advantages, which Spring OSGI will be, I think, to a large extent, instrumental in porting those to Java. So, in a nutshell, OSGI provides class versioning, which basically allows you to run multiple versions of the same class simultaneously in the same JVM. You also get dynamic modules, where you get, first of all, you get the concept of modules, but you also get dynamic module installation, deployment, and a full life cycle. So that can certainly address a lot of the dynamic issues. And Spring comes into the picture because Spring will basically provide a programming model and manage some of the harder bits that you would otherwise have to deal with if you're working with a raw OSGI API scenario. But there is a bit of a but, I think, at this point. And I'd be interested to hear what some of the Spring guys have to say about this. But basically, I still think OSGI is relatively complex. And why is it relatively complex? Well, I mean, for one, it's quite restricted in terms of exactly how you set up your modules. So, for example, it strongly encourages you to only to explicitly import all the packages that you need and to explicitly export all the packages that you're going to export. So I can imagine quite a fair amount of time dealing with those kinds of issues. And that's not really the sort of issues that most developers would want to spend a lot of time doing, because most people will be thinking, everything worked okay before we had all these modules. Okay, occasionally there's a conflict, but I usually work around it. So why am I having to bother with all this stuff? And I think the other question about OSGI in my mind is how productive is it going to be? It isn't coming from the, we are going to solve your productivity problems perspective. It's coming from almost like a hardcore engineering perspective, I think. So it's certainly going to satisfy the kind of people who, if you like, are hardcore engineers and really want to have things done in a very rigorous, well-defined way. But I think most of us really just want to get applications done. And some of the problems that OSGI are going to solve aren't actually of that much interest to a lot of developers, but at the same time aren't going to impose an overhead. So that's why I asked the question, will it hit the sweet spot? I think it's still a question that is going to be answered. I think it's going to be big, but we'll see. Right. I've got to the point in the presentation where I'd like to show you something, and I'm sure you guys are bored listening to me talking. And one of the things that I'm talking about showing you code, one of the things which I have been, I suppose you could say it's quite experimental at this point, but it's an attempt to provide a solution to some of these problems. Okay? And I'm calling it, for the moment, I'm calling it right shift. I'm sure I'll change the name, it's a bit deeper, but anyway. And the idea really is, to provide a kind of a Rails-like development experience, and I hate to use cliche Rails-like, but everyone wants to be more Rails-like, but I think people kind of know what I mean when I say it. But with one big difference, everything that's come from the Rails mold is all about scripting, and it's about kind of UI-centric type stuff. And even though they talk about how agile it is and how good it is for testing and how easy it is to write tests and so on and so forth, I do think that the focus is basically very UI-centric. So that for me is a little bit of a problem because I prefer it, certainly for the back-end components, which, as I mentioned, over time tend to get very complex. I prefer them to be more test-centric rather than UI-centric. And the second thing is, we talked about how scripting provides a dynamic capability which doesn't really exist in Java. Now, with what I'm trying to do here, I'm trying to add a dynamic capability through a Java model. So that is the idea. And I think that for large projects, the big problem with Java tends to be, I think, more a question of, our application has gotten very big, so the problem must be Java. I don't think that's really the case. I think Java is inherently a very, very easy to be productive programming language to write in, because you've got such good tool support and it's so easy to kind of churn out code very quickly. But the problem is more about the environments, and I think that's part of what I'm trying to address. So let me show you some code. Show you some stuff going on. Right. I've got a very simple application, and I mean, it's unfortunately because the stuff is all so new. Can you see that? Is that okay? I haven't even had a chance to really produce a really good example, but I've sort of started, and hopefully this will be good enough to just give you a glimpse of what I'm talking about. Basically, I've got an application, it's a wine merchant application, and the idea is you can add wines, and then you can basically search for wines, and you could, obviously go in a whole lot of different directions with it. But at this point, it just has a simple ability to be able to add a wine, and I'm going to add a little extra capability where you can get wines of a particular vintage, given that vintage is one of the pieces of data in the wine metadata, if you like, in the wine class. So what I'm going to do is coming from a test, and this test is called wine merchant test, stands for test case, and I won't tell you about this plugin spectral quite yet. As a typical setup method, if I run this as a regular JUnit test, it'll be unhappy. Yeah, so it worked okay. Now, what I want to do now is I want to kind of add to this application through the test. So, the first thing I'm going to do is this. If you look over here, I've also got a main method, and I'm going to run the main method for this test. Right, so usage, okay. So, I've just got one test method available, and that's test vintage. And if we look at test vintage here, you can see that I've got this dynamic context folder. I'm not going to tell you in detail what this is doing, but essentially what it's doing is it's managing string context. And I'm retrieving a bean called wine merchant from this context folder. Now, what I want to do is I want to add to the interface. Now, basically, just to give you very, very quick bird's eye view of what's actually going on in this framework. You've got a parent application context, and that is essentially what you're kind of interacting with in your test. But underneath your parent context, you've got child context, which I'm calling plugins. Okay, and the idea really is that plugins contain implementations. Now, generally speaking, one of the things that I've noticed, well, I guess we all have noticed it, about interface implementations is implementations tend to change much more frequently than implementations. Implementations change much more frequently than interfaces. So we don't want to have to, we want to reload at the right granularity. If we're changing the interface, we're going to have to reload at a coarser granularity than if we're just changing the implementation. So I'm going to reload at a coarser granularity at this point by just typing right. So what I've actually done now is I've reloaded the parent application context, and by typing R, I'm just going to repeat the previous test. Okay, so that's happy now. But let's have a look at the implementation that we have. We actually did have an implementation for that method that we just uncommented had all along. But if we look over here, it's empty. So let's just see what we do. I'm specifying my test behavior, and it's kind of obvious what's going on here. I've had one line, so if I call get lines of notation, I should get one back. 1996. So let's see what we've on there. Assertion failed, error, expected one was 0. And just to prove that I don't need to reload anything to run this test again, what I'm going to do is just change this to 0 just at the time being. Okay, so the test has been updated. I haven't reloaded anything. The same application context is still running. So now, put it back to what I'm actually expecting. Obviously, I know that's going to fail again. So, the question now is what do I need to do to make this work properly? How do I actually apply this new implementation? Well, first I need to write my new implementation, which I'm going to do right now. So you can see here that I now have an implementation which will hopefully work. And it still fails, of course, because I just need to reload the plugin. The plugin's name is Merchant. You can see here, this is the parent project, and that's the plugin project. The Eclipse terms. So it's reloaded that. Now if I run the test again, it's worked. So I guess you can see where I'm getting at. Basically the idea really is that to update the implementation, all I needed to do was to write the implementation, reload the plugin, and then just run the test. And you can see there's no, the test is actually running the whole time. There's an application running the whole time, so all I need to do is just fire off a command that I want to fire, and off it goes.
So this is a suggested way to handle an application with lots of classes, then you just want to update one implementation.
Exactly, yeah. So the question is, how would this translate into a large application? Yeah. I mean, at the moment it's an extremely simple application, so you're probably not really seeing very many benefits from it. And what you actually want is a much larger application to see benefits, but just imagine what it would look like. You would have over here, wine order, that's a parent project, then wine order merchants. And you might have a whole bunch of more sub-projects, and each of them are effectively plugins. And you could have one, for example, for your Hibernate session battery, because that's something that you don't really want to have to load very often, because it's quite expensive to load. So possibly want to keep it kind of away from everything else. But it's still nice to be able to reload it when you're changing mappings, things like that. And then you have a whole bunch more. And what you're trying to do is try to get only your effectively your domain classes and your interfaces in the top level project. And in the plugin projects, you have all the implementations. And then it's a question of then restructuring the right granularity. Obviously, the smaller the granularity, the more projects that you'll have. And there's probably a kind of a trade-off to get to the right place there. Does anybody else have any more questions about this?
As I understand, is this really for an integration style test where we're testing full end-to-end? Because ordinarily we're testing a unit of work. I've got multiple services and I'll just test our project, and then if my initial context loads in a matter of seconds, I wouldn't need a separate application running.
Yeah. Yeah.
So I don't expect to size the application because you break it down into multiple stream compute files.
Yeah. Yes, it is very much designed for integration testing, but I think that even if it is in terms of code base, tends to be a fairly sort of small portion of your overall test code base. The integration tests, they tend to occupy perhaps the largest amount of time in writing and managing, because one is less productive writing integration tests than one is writing unit tests and mocks. In terms of the kind of build, deploy, test life cycle. So that's where it's happening. So that's one solution, I think a nice potential solution for some of these problems, because what you get is dynamic behavior. You're still within the Java model. You're still able to use all the kind of capability that you're going to get in the Spring. You don't have to adopt an entirely new programming model. You can still use an existing programming model. And with some extra work, obviously, into this, I think that you can then have the benefits of, if you added some IDE support instead of just having the command line tool that's showing you there. And in addition to that, you had, say, some more powerful runtime support. Then I think that you have something quite powerful in this framework. So, I guess I don't want to sort of overtake my time, so it's really a question of how much time have I got? When should I stop? So
I think we've got another 15 minutes actually.
15 minutes, okay. So I can probably talk through a couple more things, because there's a couple of other quite, I guess, neat little tricks, which kind of dovetails to a certain extent with some of the things that
Sorry, in the previous talk, is that something we can do now? Or this is just an idea?
Well, I mean, it's working. You can do it in the sense it's working, but I haven't published the code anyway. And it's very early days. And I'd like to obviously publish it to an open source project of some sort. As soon as possible. But it's obviously a question of getting it to a point where it's stable enough that it is going to be usable before I can start telling the whole world about it. But yeah, I think it's hopefully I'll get enough time to work with it. So a couple of other elements that I want us to talk about. One is what I call smarter imports. And I was telling you earlier on about some of the problems with imports, where effectively a situation where you get the encapsulation, but you don't really get the ability to easily override existing definitions through an import. And this next technique that I want to show you gives you the capability of doing that.
Can I just clarify what you mean about imports? Is that in the config file, in the Spring config file?
Exactly, yeah. I'm not sure if you've come across it. It's basically, it looks like...
I've come across it, but I thought it wasn't implemented by Spring. I thought they were implemented by Spring, but Spring implemented used multiple files that were implemented by Spring.
There are different ways of doing it. But, I mean, this is import, resource equals, and then import to context.
Yeah, so is that just a separate context XML?
Exactly.
Yeah. Do you import from within that? Just to use it for the whole thing?
You can have imports from that to other files.
Yeah, no, I know.
Yeah.
You can't just import bean food from the context file. You have to import the whole thing from that.
Yes. Yeah. That's certainly yeah, basically that's how it works. So I'll show you. Right. This is a kind of a variation on this technique. Now, what we've got here is going to show you the application context being created. And the key thing here is we've got this file here called bean-set context. And so now normally what would happen here is you would have if you like, a hard-coded definition of an XML file to import to. So in this case, it could, for example, resolve to import to context. So, for example, now I've got this test here. What's happened here is I have this bean set context. I have this bean called bean1, okay? And I have another resource called import to context, which I'm bringing into my application context, which defines beans my ID2 and beans3. You can see here the classes B2 and B3. Sorry, the examples are extremely noisy, but I think you can see what I'm getting at. So, let's say, now, try and think of a slightly more sort of real-world situation where actually what you want is you want to import, say for example, B2 implement some interface. But now, you still want the import, you want the ability to be able to import, but you actually want to import a whole bunch of other definitions which are completely different to the one that you've got at the moment. So that is really a situation that I'm sort of trying to address with this test here. Now, specifically, I have this alternative context, which for being ID bean2, actually, the implementation class here is this impl bean4. Okay, that's what I want. And I don't care about bean3 anymore. I'm not interested in that. That's my scenario. So the original setup basically brought in bean1, bean2, and bean3. Okay, and that was fine. Now, the second time around, what I actually want is instead of, when I bring in bean2, instead of bringing in an instance of bean2, I actually want to bring in an instance of bean4. So my example doesn't really make any sense. Anyway, and I don't want it, I'm not interested in bean3 mean. So if we do actually, if we don't get a no such being definition exception, I want to fail it. Yeah. So that's basically the capability that you get through this. Being set concept. So essentially what you do is, rather than have a hard-coded XML file that you are placing as a resource, you're saying, I want to have a logical import. And the question is, how do you actually resolve that logical import? If we come over here to bean set properties, we have bean 2 and 3, which is a logical import there. Bean 2 and 3. And that actually resolves to imported context XML. That's our default case. Yeah. Now, if we want to override that in the test, all I do here is I have this properties file, which basically I load from this bean set properties. Now, all I do is say, instead of using imported context to resolve beans B2 and 3, the logical imports, I'm instead going to use alternative context, which basically has just a single bean definition. If I run that test, then that's happy. So, does that make sense? Does everyone see where I'm getting at from this? Can you guys imagine situations where you think it might be useful to do that? Because, I mean, for me, this particular feature completely transforms the way that we use Spring throughout our entire project. Because previously what we were doing was, in all our integration tests, what we do is we have to have lots and lots of extra override files to stub out various bean definitions. And as a result, the original imported mechanism didn't really work properly. So this basically allowed us to, if you like, get the encapsulation that you get from the imported bean mechanism. But when you want to do your overrides, you simply just change the property and job done.
Phil, is the import. I myself have hardly used that feature, but that's a standard part of Spring.
Yeah.
So you're not actually replacing the import. You're adding more extra functionality to perform a logical import.
That's right. Yeah. So, I mean, effectively, the process at which that resource, effectively the process at which this string gets read and dealt with is basically being overridden and replaced with something which is doing this extra stuff.
What's the other?
It's actually, it's quite minimal, because one of the things that it does is, well, just this particular implementation, is it keeps track and remembers files that it's already imported. So you can import the same context file from as many different parent files if you like.
So the story looks half the ice cream.
Sorry?
The story looks half the ice cream.
As it's kind of going through, so as it's kind of, say, importing a large application context, lots of application context XMLs which are all importing each other. All kind of, some of them might be importing, let's say you have your DA might be imported by lots and lots of different application context XMLs. But what happens is it just remembers that it's already imported that one, so it's not going to import all those bean definitions again. So, I mean, the overhead is fairly minimal. I'm trying to think, I don't think I've got time to tell you about all of these, but I can probably maybe talk about one more, perhaps.
Yeah.
What do you reckon?
Yeah, and skim over the rest. And
Okay.
just
One which is quite nice, and I can probably go through this one very quickly, is this works quite nicely with the import mechanism. And this is in testing. One of the things that you find is, Spring's really good at being able to provide mock implementations of collaborators that you don't need for particular tests. But when you find that you're having to create a new sort of stub implementation for each and every collaborator, it starts getting a bit boring. So there's this little feature with dynamic test proxy generation, and I'll just show you what's going on there. Right, so what we've got here is we've got a client bean which refers to a collaborator. Okay. And then it calls, when its do stuff method gets called, all sorts of methods get on the collaborator get called. Now, again, I'm sort of asking you to project your imagination a little bit beyond what I've actually written down here. But basically, imagine this is actually quite a complex class with lots of different dependencies and doing lots of different things. And you're interested in testing a particular method, and you don't want real implementations for all the collaborators because they might be drawing dependencies from each and everywhere. So what you want to be able to do is effectively dynamically stub out particular collaborators. So what I'm going to show you is not that whole big test, that whole big class, but just that simple mechanism of being able to dynamically stub out the collaborator. So if we look at the Spring context, we can see here we've got a client being here, and we've got a reference to a collaborator here. But now, where's the collaborator? Because if you look at the test, you can see I'm only using one Spring context XML file. So obviously, it's going to throw a no such bean definition exception. In fact, I basically just see if I can just do this really quickly. If I just do the, that's a sort of standard bean factory that gets used in Spring. So if I run the wrong test. So here we go. Throws no such bean definition, no bean name collaborators is defined. Okay. Now, I don't want to have to go and jump through the hoops of creating a mock collaborator which doesn't actually do anything in any of its methods. So what I do is I just use this proxy creating bean factory and just pass that through. Now you can see what's actually happened is when the collaborator calls, it just has kind of do nothing methods. So that's quite useful, not a particularly difficult technique to apply because all you need to do is you obviously need to vary slightly the way that you might otherwise create your application context. But there's not really much to it. I mean, the actual implementation of that proxy creating the factory is fairly simple. It's going to save you. Could save you a lot of code in the long run.
So does this exist, or is this another thing you create?
It's just part of the same project, yeah. It doesn't really exist in any kind of public format. It will be at some point, probably quite soon.
Yes, I mean that's a really good one.
Yeah.
You know, for a similar thing, what I've done in the past is create parallel Spring file with creating JMOD mocks for all classes.
Right.
And then you can tell them exactly what you want to do with all the expectations.
Yeah.
But this, not a proxy, you mentioned mock, we're creating mock objects. The mock creating bean factory is better because that would just say you have a very layered application, create two Spring configs, one for real.
Yes. Right, yeah. But now when you create your mock, creating Spring factory, are you creating expectations with your so you're just basically using to stub up
it injects all the mocks into the test instead of expectations from split the test and test all the dependencies.
Right, okay. So it's similar sort of technique, but
but this you don't have to do
you don't have to do anything. Yeah. And this actually works very well with in fact the importing mechanism, because effectively what you do is you say, for any collaborator that you don't want to include in a particular test, all you do is you effectively map it through the import mechanism to a application context definition XML file which has no B definitions. And as long as you've got it set up so that it's using this proxy created in Bean Factory, then it automatically just creates a dynamic proxy for any of those collaborators if they don't exist. So it just makes it very easy to effectively stub out very large chunks of an application that you're not using for a particular test.
I take this is using the Java proxy, so it's proxying the interfaces and not classes?
Yes, it's using the
CGD.
That's right, yeah. In this case it is, yeah. So, probably not enough time to go through anything else, but I'll just tell you very briefly a couple of the other things that I've been looking at. One is the idea of an externalized configuration file, because typically what you find is you have this property placeholder configuration mechanism, which I'm not sure, how many of you guys are familiar with that? So basically, instead of actually having to have configuration values in your application context XML, you externalize it into a properties file, which typically be loaded from the class file. But now let's say you want to override that with some external system on external location in the file system, so that an administrator might come and maybe just add one new property or just tweak this perhaps one or two properties in that file. You want to be able to do that and still have most of your properties coming from, if you like, the version of your property file that's sitting in the class file. And that's basically what this externalized configuration mechanism does, which is quite handy, I think. Certainly makes it a lot easier to say, because all you have to say to your administrators, if they need to change a particular value in, say, some configuration file, just say, go to, ops, whatever, and it's not, they don't have to control line to, into the guts of your application to go and find it. Expandable context. I mean, that idea is also quite simple. The idea that you create your application context, and to show you the test actually. The idea that you basically create an application context, and the idea is that you want to have the option of being able to add additional bean definitions to that application context after it's loaded. And simple case of just setting up a context monitor, which is going to look in a particular file for new files that have been added, and when it finds it, it'll just automatically just bring those bean definitions into the application context. So you have a way of, if you like, dynamically expanding your application context without actually having to reload anything or change anything. It just kind of grows. That's a technique that's here. If you look at what's actually happening in the output, basically in the test, what it's doing here is it's spinning on a loop, waiting for a second, and catching the no such bean definition exception, and then just logging it. And then if it's not catching the no such bean definition exception, it basically means that it's found a bean, and it's logging that as well. So if you look at the output, you can see here that for the first few times it's been waiting, it's been looking, it hasn't actually found anything, and at some point it basically kicks in and says, it's added that location, it's found that bean. So that's just showing that particular mechanism at work. So I think probably time for me to summarize and give you a little chance to have a go. I think that there's only no doubt about Spring's value and quality, and certainly I've used it a lot, and it's been very, very helpful in projects that I've worked on. But I think to a certain extent you can say that it is stretched by large, complex, and dynamic projects. If you look at Spring 2.1 and the kind of features that are being offered, there's an awful lot about new ways to manage beans within an application context, and new ways to load beans, and new ways to kind of apply AOP and to load beans using annotations and so on and so forth. But there still isn't a whole lot on actually managing interactions between large application contexts. I think that's something which I think there is room for improvement. And certainly now we see with I suppose you could almost say Rails revolution, developers want more and more productivity, and you're seeing that with the likes of Rails and other projects, seeing that there's quite a shift in that direction. Developers want more productivity, there's absolutely no doubt about it. And I think that there still is some room for improvements, and I feel like in the Spring application space for providing all of that. OSGI is a potential solution to some problems, particularly problems of organization and making stuff dynamic. But I still think that, I still question whether it is the right solution to every problem. So it's definitely an interesting technology worth watching, and I'm sure it will be quite a success. That's it. Does anybody have any questions?